Hello, welcome to my YouTube channel. My name is Nanye Abraham. I'm a graduate of Kwame Nkrumah University of Science and Technology, BSc Mathematics. We have started a series of lessons, and so far we have done a lot of topics. And in this lesson, we shall be looking at differentiation of common function, differentiation of common functions, and it is also called a general rule. Now, in our previous video, we learned about differentiation from the first principle. We learned from the differentiation of first principle, and in this lesson, we are continuing with the general rule. Now, a general rule for differentiating y equal to axn emerges where a and n are constants. Where a and n are constants. So, it means that we can only use general rule and then be comfortable when these values a and n are constant in a function given. It means that they should be numbers. If they are not numbers, then you will use it, but you wouldn't be so comfortable. So to be comfortable with it, a and n should be what? Constant. A here and then n they should be constants. Then you'll be comfortable. I also want to let you know that in differentiation, we represent distance as differentials. So for example, in our previous video, we have learned about the y over the x, and then change of y, or change in y and then change in x. We also have f of what? X, f prime of x, which means that differentiation of a function. That is, if the function is given in f of x, then y prime or y prime of x. This, when the function is given in y, these are some of the things, or these are some of the differential functions we have. So you will not be confused when you are being given some functions in to differentiate, or you see such things in books. They all mean the same thing. So for example, now, so we have learned that here we have stated that the rule is y equal to ax raised to the power n. What you do is that you just pick this word n at the top here, that is the power, multiply it by the whole function, and then subtract 1 from the power. That is what you do, and that is what you are doing here. The y dx, that is what we are looking for. The y dx is equal to an is the n here. They multiply it through by the function, and then subtracted 1 from the power, or the index. Now I also want to let you know that whenever we differentiate a constant, then the function becomes 0. The function is equal to 0. Now also, differentiation can be done in multiple form or multiple ways. I mean, you can differentiate multiple number of times. So for example, if you are having f of x to be equal to x cube, you can differentiate this thing multiple number of times. So that is where you see some things like f prime, somewhere you see f prime prime, f prime prime prime. It means they have differentiated this one only once. If you differentiate it twice, then you say f prime prime. If you differentiate it thrice, then you say f prime prime prime. That is what you'll be seeing. Or if you don't see this thing, you see the y dx, you see the y square dx square. You also see something like keep. This just tells us that this is the number of times. The order is what? 2. So it means that they have differentiated it what? 2 times. Here once and here thrice. This is what it means. So let's use our general principle or the general rule to differentiate distance. Some of the simple functions we will know. So for example, if I'm being given equal to y equal to 4x cube, to differentiate this, what I'll just do is, this implies that y prime is equal to, multiply this by the coefficient, it will be what? 3 times the whole thing, which is 4x cube, and then subtract 1 from what? The power, and that will give us what? 12x raised to the power 2. That is all what the general rule is saying. 1. 2. Let's say you are being given f of x to be equal to 12x squared plus 13x to differentiate. Now if you differentiate this, it will be 2 multiplied by 12 will be what? 24x, then subtract 1 from what? 2 plus 13, that is 1 multiplied by 13, that will give you 13, x 1 minus 1. So this will give us 24x plus 13, x raised to the power 0. X raised to the power 0 is, in indices we know that x raised to the power 0 is 1, so it will be what? 13. It will be 13. You can use the first principle rule to solve this thing, and you get the same answer as this place. Now also the last preliminary is, if you have been given fx to be equal to maybe a constant 5, if you differentiate this thing f prime of x, what you are going to get is, you're going to get what? 0. Anytime you differentiate a constant, it doesn't matter how huge or small the constant is, you should get what? 0. You should get what? 0. So anytime you differentiate a constant, you are going to get what? 0. So in a general rule, these are some of the simple things. I would love you to keep them in your head. Just keep these things in your head. You should know that anytime we are differentiating a function, now this is a function given in y or f of x, and this is the differential form in dy dx, or in this form. So anytime you are being given a function like this, what you need to do is, when you differentiate this function, this is the form you are getting. For example, if you have 4x, you differentiate 4x, you are going to get what? 4. Or let me say 4x cube, you are going to get what? 12, because you take this 3, multiply it by this 4, and then subtract what? 1 from the what? The power of the variable, which will be what? 12x what? Square. And we are learning this newly, that whenever we differentiate what? Sine x, if you are being given a trigonometric function, and for example sine x, and you are being asked to differentiate it, whenever you differentiate this function, you're going to get what? Cos x. And then whenever you differentiate cos x, you're going to get minus sine x. Please keep this in your head, because we'll be using them. And then whenever you differentiate this exponential function, we call this exponential function. When you differentiate it, how you do is that you first differentiate the top, or the power, in terms of what? X, or with respect to x. And so when we differentiate this thing with respect to x, a is a constant, x is not, the power of x here is what? 1. So we're going to get what? A. So what you do is that you multiply a by the function again. That gives you what? The answer. So For example, if you are being given something like let's say e raised the power 4x. If you differentiate this 4x, you're going to get what? You're going to get 4. So multiply 4 by the whole function, and that is how you differentiate this thing. And whenever you are being given lane, let me use lane x, not lane ax, lane x to differentiate. Whenever you are being given lane x to differentiate, you differentiate it, you're going to get 1 over what? X. 1 over x. 1 over x. Please keep this thing in your head. Keep them in your head. They are something you need to keep in your head, and then you don't forget about them. So we want to solve these examples. We want to solve the examples here. For example, the first one, we have y equals to 5 over keep root of x raised to the power 4. How do you solve this thing? To solve this, we need to change this, because we are using the general rule. To use the general rule, change this to the form you can use the general rule, which will be 5 whole number. This can also be written as 1 over x raised to the power 4 or raised to the power 1 over 3. This thing can be written like this. Now this can be changed to 5 multiplied by 1 over x raised to the power 4 over 3. 5x raised to the power 4 over 3. And it can be changed to 5 multiplied by x raised to the power minus 4 over 3. 4 over 3. This is indices, and I am not going to waste time on this. Please, so if you don't understand indices, go back to indices and then revise them. You will understand this is just indices. So we now have our y equal to 5x raised to the power minus 4 over 3. Now our y prime can be equal to our y prime, that is the differential function. Our y prime can be equal to you take the minus 4 over 3, multiply it by the 5x minus 4 over 3 minus 1, and this will give us minus 20 over 3 x raised to the power minus 7 over 3. When you continue to simplify this, you're going to get minus 20 over 3x raised to the power 7 over 3. Please, the answer, let me write it boldly here, is minus 20 over x raised to the power 7 over 3, and that is the answer for the one. Number two, we are differentiating with respect to x. Y is equal to 5x raised to the power 4 plus 4x minus 1 over 2 x square plus 1 over root x minus 3. Just like we did in the other one, you have to change this equation to the form we can solve simply. So this is equals to y raised to the power x raised to the power 4, 5 times x raised to the power 4 plus 4x. Now we can change this simply by factorizing 1 over 2 out and then make our x minus 2 indices plus our x raised to the power minus half minus 3. Now if we are solving this, our y prime is equal to 20x cube plus 4. Then this multiplied by this will give us plus x raised to the power minus 3 plus this will now be minus half x raised to the power minus 3 over 2, then minus 0, it's a constant, minus 0 is a constant, 3 is a constant, so it will give you 0. So in that case simplifying this completely, you're going to get 20x cubed plus x minus cube. Let me just change it completely. Sorry. Y is equals to 20x cubed plus 1 over x cubed minus 1 over x 3 over 2 plus 4 minus 0. And our answer is equal to 20x cubed plus 1 over x cubed minus 1 over x 3 over 2 plus 4. That is our answer for that question. Now our last question says that y is equals to this. Find the differential coefficient of y equals to this. 3 y is equals to 3 sine 4x. 3 sine 4x. When we are differentiating this with respect to x, what we said is whenever we differentiate sine, it becomes what? Cos. So our dy dx is equal to the sine will now become what? Cos 4x. Cos 4x. Cos 4x. But what you do is you differentiate this thing alone. So when you differentiate the inner one of the cos, what you get 4. Multiply that by the whole function, so it will now be that multiplied by 4, the whole function, and this will be 4 times what? 3 cos 4x, which will give us 12 cos 4x, and this gives us our answer. Now example B says f of t is equal to 2 cos 3t. F of t is equal to 2 cos 3t. What you do is the same thing. When you differentiate cost, what do you get? You get minus sine. So it will be what? Minus, I'm doing this straight. I won't. So it will be f prime of what? T. F prime of t is equal to minus, you differentiate cos, you get sine, minus 2. Now if you differentiate the inner thing here, you get 3. Multiply 3 by this cos, but because we have differentiated, it will now be what? Sine. It's no more cos again. Sine 3t. Your answer is equal to minus 6 sine 3t. Minus 6 times sine 3t. Now the rest of our work is assignment that you solve by yourself. Or write the answer down, you solve and see if you get the same answer. So these are the assignments I'm giving to you. You can solve. I've written the answers down. Please solve and see if you'll be correct. And thank you very much for watching my YouTube videos. The name again is Nenye Abraham. Please kindly subscribe to my YouTube channel and turn on your notification bell to receive my uploads anytime I give a new upload. Thank you very much. Bye. I'm out.